Storybox Audio.
Please like and subscribe. Thank you. So today we'll be looking at structural mechanics. So these are support that we are going to be using to solve some example. So example of how to get the free body diagram of this support. So for simple support, which is also known as roller support. So the body diagram, we can see we are having a support at the both left and right side. So a force, the body diagram of it, we are going to be having just a force, upward forces acting, will be acting at the edge. So for inch support, so for inch support, we are going to be having a vertical support, which is at the left and right, and we'll be having a horizontal also. So for inch, we have a vertical and horizontal at the left, and then we have a moment. Then at the right hand side, we have only a downward forces and we have a horizontal forces acting. So we are going to look at computation of reaction and moment. So the first one says upward force is equal to downward force, which means upward force will always equal to downward force. We balance downward force. For horizontal forces at left, we balance or is equal to the horizontal force at right. Then for clockwise direction, we balance anti-clockwise direction. So equation of equilibrium or equilibrium equation. So we have the summation of all vertical forces will equal to 0, and the summation of horizontal forces must also equal to 0. Summation of moment is also equal to 0. So we are going to look at example 1. So we can see that we are having a support. So at this support, we have inch support at this left hand side, and we have roller, which is also known as roller at the other side. So then we have another forces acting downward at 20 kilonewton. So the distance from here to this place is 30 meter, and the distance from here to here is 20 meter. So for us to solve this solution, we need to draw our free body diagram. So our free body diagram will look like this. We know that for inch, we are going to be having a horizontal force at A, which we are going to be having two supports, horizontal and vertical. Then for roller, we just have a vertical forces acting at B. So this is our free body diagram of this equation. So the distance, we know that the distance given is 30 meter and we have 20 meter. So the next thing we are going to do is that we need to solve for using equilibrium equation that says summation of all vertical forces must equal to 0. So to do that, we know all the vertical forces. These are vertical forces. So what we are going to do is that we are going to be using a sign. So we are going to be using this graph sign. Any force going downward, we are going to make it as negative. Then any force going upward will be positive. So we can say any force going downward will be negative, and any force going upward will be positive. So summation of vertical forces, we have reaction force at A plus the reaction force at B. Then this is negative, that's minus because it's going downward, minus 20, then we make it to equal to 0. So from here we can say reaction force at A plus reaction force at B is equal to 20. So from here, so the next thing we are going to do is that we are going to apply moment to one of these, either this or this. So let's look at what we mean by moment. Moment is equal to force times perpendicular distance. Force times perpendicular distance, that's moment. Our moment is equal to force times perpendicular distance. So from here, take a moment at this place, so we are going to take our moment here, so we can say summation of moment at A, then we make it to equal to 0. So it means we are taking our moment at point A. So when we take our moment at point A, which this point, which means we are going to make the summation of all the moments at point A, we are going to make it to equal to 0, which means all the force acting here will be 0 for now. So from here we are going to start calculating from B. So therefore we are going to say calculating from here now, which means the first one we are going to be having is RB. Then we are going to multiply it, the force, that's moment says force, this is our force, multiplied by the distance. The distance is the addition of these two, from where the force is to where we are going to take the moment. So the force, that will give us plus, that's times multiplication times the distance. The distance will be 30. So the addition of the distance, that's 50. When we add 30 plus 20, is going to give us 50. So we have the next force we have is this, so that's minus 20 multiplied by, then the distance will be 30. The force is vertical, which is negative. Then from the force to where we are taking the moment, the distance is 30. So we don't have any forces again, so we make it to equal to 0. So from here, 50 RB minus, then we multiply this together, that will give us 600 equal to 0. So we move 600 to the other side, so we'll be having 50 RB will equal to 600, so that our RB will equal to 600 divided by 15, and that will give us 12 kilonewton. 12 kilonewton. So the next thing we are going to do is that we are going to say, but from our summation of vertical forces, we have this, that but RA plus RB is equal to 20. So we know the value of RB now, so we can substitute, so that we're having our RA plus our RB, which is 20 kilonewton, sorry, which is 12 kilonewton. So we have 12 equal to 20, so we move 12 to the other side, we have our RA to equal to 20 minus 12, and that will give us 8. So which means our RA is equal to 8 kilonewton. 8 kilonewton. So that we'll be having our RA equal to 8 kilonewton, then our RB equal to 12 kilonewton. Thank you.